This is R.D. Sharma solution class 12 chapter 19. Exercise is 19.8 indefinite integrals we are taking. This is x plus log x in the denominator, and when you see that we will put it as t, you'll get this x plus 1 by x. So this t will be equal to x plus log x, and it's all about differentiation. So this dt by dx will be equal to, this content should come as the numerator and one part of denominator should come. So 1 plus 1 by x. When you take the LCM, it will be x plus 1 by x. So dt will be equal to x plus 1 by x into dx. So this whole is dt. Now let us take this. This integral will be integration of, this is dt. Then we have t. So the formation will be ln modulus of t plus constant of integration. And this ln modulus t, what was t? It was x plus log x plus constant of integration. This is your answer. Okay, this is the solution I was talking about. So please remember to let the examiner know that you know this log x is log base ex. Alright, here sine inverse x, the differentiation is simply 1 by under root 1 minus x square. So you know how to do this now. This is the only catch in this question. When we put t equals to sine inverse x, dt by dx will be equal to 1 by under root 1 minus x square, and this dx goes here, so you'll get this part, this part you already got it through dt. This integral will be, this is dt, and since we are at the 40th question, you are aware that how to solve this. What is the result? So 2 plus 3 sine inverse x will be t only. When you take this 1 by ax plus b integration, you will get 1 by a ln modulus of ax plus b plus constant of integration. So this is what we are going to do here. Integration of this dt by 2 plus 3t, equate it with 1 by ax plus b. So 1 by 3 ln modulus of 2 plus 3t plus constant of integration. 1 by 3 ln 2 plus 3, what is t? We assumed it to be sine inverse x. So just replace it by this plus constant of integration. So how do we write it? So this is the way you are going to write it. Let, putting, since, all the symbols, implies, is equal to sign. Please don't forget. So this one is more easier than the previous question. See, normally people would do 10x equals to t they will put. But when you see a constant, it's going to be 0 when it is differentiated. So just take t equals to 2 plus 10x. When you differentiate both the side, dt by dx will be sec squared x. So dt is equal to sec square x into dx. This is the numerator. Sec square x into dx is dt. So you get this. So integration will be equal to integration. This is dt divided by this 10x plus 2 or 2 plus 10x will be dt. So integration of ln modulus of t, ln modulus of t. T was 2 plus 10x or 10x plus 2. So now write it like this, ln modulus of 2 plus 10x plus c. So this is the solution I was talking about. So it's a straightforward one, but don't forget about this let and putting, etc. Okay, almost similar. Sine 2x will give you 2 cos 2x, 10x will give you sec square x, minus 5 will be eliminated when we differentiate it. So t will be equal to, we'll put t equals to sine 2x plus 10x minus 5. When we differentiate both the side, dt by dx is going to provide you cos 2x, actually 2 cos 2x, because the differentiation of 2x will also yield 2. 10x will be sec square x, this will get eliminated. So this dt will be equal to 2 cos 2x plus sec square x into dx. So this integration will be integration of dt, this whole numerator I am talking about, and then the denominator is already t. Now you have a straightforward solution. ln modulus of whatever comes inside, which is t only, which you initially imagine. It's going to be sine 2x plus 10x minus 5. So in place of t, because the result would be ln modulus of t plus constant of integration. So I'm just bypassing one step. So this is the result I was talking about. So this is the whole way you have to actually write it. Now we have sine 2x divided by sine 5x, sine 3x. Now even if you put anything of the denominator, you are not going to get anything from the numerator. Or numerator will not give you the denominator. So one reasoning can be 5x and 3x will get you 2x. That is 5x minus 3x is equal to 2x. So this sine 5x minus 3x is actually sine 2x. This numerator sine 2x, which we have written as sine 5x minus 3x, is sine a cos b minus cos a sine b. Sine a minus b formula is sin A cos B minus cos A sin B. You know already about this. What is in the denominator? Sin 5x, sin 3x. Now take them separately, that is take the denominator with each term, sin 5x and sin 3x. Now just cancel those terms which are common. So you will get this cot 3x minus cot 5x. Cos x by sin x is cot x. See, cos by sin is cot. Sin by cos is tan. So integration of cot 3x minus integration of this cot 5x. Cos 5x by sin 5x is cot 5x. Now cot x directly you can integrate. So cot x ln and modulus of what? Cos by sin. Okay. So ln modulus of. So this cos by sin, whenever you see this p by q form, the denominator will come. Always in integration, remember that. So ln sin 3x, ln sin 5x, but 3x will be differentiated. 3 will be in the denominator. 5x will yield 5 plus constant of integration. This is your final result. So this is how you can get this. 5x minus 3x is 2x. If you can imagine that, this question will be a piece of cake for you for sure. 1 plus cot x divided by x plus log sin x. So again, let me tell you, this type of question we have already done. T is equal to x plus log sin x and is equal to differentiate. When we differentiate 1 plus 1 by sin x log and then cos x. Sin x is cos x. So 1 plus cot x will come by itself. This numerator we are talking about, 1 plus cot x into dx. So this dt and dx we can take on the right hand side. So dt by dx was this one. When we take dx on the right hand side, so we'll put it like this. Integration of numerator is dt, denominator is t. So this is ln modulus of t plus constant of integration. So ln modulus of t is what? T is what? X plus log sin x. X plus log sin x plus constant of integration. So this is the way you are going to actually write it. See, learning and understanding is different, but writing is, you have to write every expression, every thought, whatever you do in saying someone, talking to anyone. That's how you are going to write. So 1 by under root x, 1 plus under root x. Now this, if you put t equals to 1 plus under root x, you are going to get this 1 by under root x. See, dt by dx is 1 will be 0. Root x differentiation is 1 by twice of under root x. 1 by 2 under root x, how has it come? You know already. Differentiation we have done a lot. So this 2 goes here. Dt will be equal to dx by under root x. Now dx by under root x is already there. See, this one is already there. It's 2 dt. So wherever this dx by under root x you encounter in this question, just put it as 2 dt. 2 I have taken outside. So it will be simply 2 ln modulus of t plus c. 2 ln, what was t? T initially we assumed to be 1 plus root x or root x plus 1 plus constant of integration. Now this is the solution. Okay, this is a different kind of question actually. But whenever 2 tan theta comes, please remember, apply the formula of tan a plus b or tan a minus b. That is what is going to give you the result. Because tan 5x can be written as either tan 2x plus 3x or tan 3x can be written as tan 5x minus 2x. So these are the combination. Tan 5x minus 2x is 3x, tan 3x. So this tan 2x plus 3x, tan a plus b, which is tan a 5x, is tan a plus tan b divided by 1 minus tan a tan b. Alright, tan a plus tan b by 1 minus tan a into tan b is tan a plus b. So what is the faida? What is the result? You are going to get tan 2x, tan 3x, tan 5x when you multiply, cross multiply these two terms. On the left and right, if you cross multiply, this cross multiplication I am talking about, tan 5x multiplied by 1 minus tan 2x, tan 3x. So I am multiplying it, tan 5x first term and tan 5x, tan 2x, tan 3x. You can write it as tan 2x, tan 3x, tan 5x. On the right hand side, it will be tan 2x plus tan 3x. Now what do you see here? You see that the question is already being formed from here. And in terms of those terms which we can integrate easily, very easily. So this tan 2x, tan 3x, tan 5x, negative sign is also there, okay? This is negative. Tan 2x, tan 3x is already there on the right hand side. Tan 5x goes on the right, so it will become negative one of this. Negative tan 5x. Okay, this negative is already there, so just take this negative on this side and you can just swap terms so that it becomes the way we are used to see it. That is, I am taking the term first to make it aligned. So this tan 5x will be ln modulus of integration. So integration of tan 5x will be ln modulus of sec 5x. 5x will give you 5, that goes in the denominator. Similarly, two negative terms are there, tan 2x and tan 3x. Let us do the tan 3x first. It will be ln modulus of sec x, and differentiation of 3x will give you 3, so it will come in the denominator. Tan 2x will give you ln modulus of sec 2x, and what is the differentiation of 2x? It will be 2. So this is a kind of different question. You must do it once so that you understand that how to do the question like this. 1 plus tan x into tan x plus theta into dx. Now this is also a different kind of question, but do remember that this tan a plus b formula we have just used. Tan x plus theta is tan x plus tan theta divided by 1 minus tan x into tan theta. Okay, now tan theta is a constant here, so it will be multiplied by tan x. You have 1 plus here also. Now multiply this tan x inside. Now you'll see what do we get. We will get some cancellation in the numerator. So just take this 1 minus tan x into tan theta here. 1 minus tan x into tan theta. Then the cross multiplication. Tan x into tan x will be tan square x, and tan x into tan theta will be tan x tan theta. So tan square x plus tan x into tan theta. Denominator will be, when you cross multiply, so this tan x into tan x gave you tan square x, and tan x into tan theta gave you tan x tan theta. Denominator will give you 1 minus tan x into tan theta. What is the use? These two gets cancelled. And also 1 plus tan square theta is sec square theta. Sec square theta is 1 plus tan square theta. So you can just replace this 1 plus tan square theta by sec square theta. So numerator becomes sec square theta or sec square x, not theta. Sorry, I must correct myself, because here tan theta is a constant, tan x is a variable. So sec square x dx divided by 1 minus tan x into tan theta. Alright. Now tan theta is constant, so don't worry about that. Tan x will give you sec square x. If you put tan x equals to t, this dt by dx is going to give you sec square x. So dt becomes sec square x dx. So what do we get? Numerator is already dt. Denominator is 1 by 1 minus t into tan theta. Now don't get confused that tan theta is there, because just assume tan theta is some a or b. It's a constant. I'm reiterating again. Don't get confused by this tan theta. It's just a constant. I'm just saying 1 by ax plus b. The integration is 1 by a ln modulus of ax plus b. If it is 1 by ax minus b, it will be 1 by a ln ax minus b. If it is 1 by b minus ax, in the case, see, 1 minus t tan theta is almost equal to 1 by b minus ax. So it will be minus 1 by a ln modulus of b minus ax. So just assume it to be b minus ax, b is 1, a is tan theta, x is t here. Because t is a variable, because we have taken t as tan x. It was all initially x. We assume t to be tan x, so we have introduced t, which is a variable. So again, negative will come, as I just suggested you. So there will be a negative, okay? 1 by a will always be there. What is a here? Tan theta. It will be negative, because negative is there. When it's just 1 minus t into tan theta, you just differentiate it by t. You will get what? Whatever you get is to be kept here. You will get a negative. So negative 1 by tan theta, and the log will remain like that. Ln modulus of 1 minus tan theta tan x, because t was tan x. So it would have come 1 minus t into tan theta. I replaced t by tan x. So that is why we have 1 minus tan x into tan theta plus c. Now this is your answer. You can just stop here. But if you really want to go ahead, let me tell you, minus cot theta into ln 1 by 1 modulus of 1 minus tan x tan theta plus constant of integration is your final result. But you can just take this sin tan x as sin x by cos x, tan theta as sin theta by cos theta, and whatever result comes, you can just make it easier for the user or for the examiner to understand. But let me reiterate once more. Okay, this is the answer. This the penultimate line which I have written is the final one. So tan x will be sin x by cos x, tan theta will be sin theta by cos theta, and a negative 1 on the as the power or the as an exponent will take this 1 minus tan x into tan theta in the denominator. So 1 minus tan x tan theta comes in the denominator. So 1 minus sin x by cos x, and this is tan theta sin theta by cos theta you can do. You can do all the cross multiplication in the denominator. The numerator will go up, and whatever is the result, you can just replace this in place of 1 by 1 minus tan x tan theta. So this is just for you to complete the question. I'm just saying we have already got the answer. So whatever I'm doing right now, some people may just skip because this is just a way of writing the answer, because the integration has already given you the answer. The examiner has not told you that integrate and then simplify. No, they have just given you an integration sign. Integration once done, you are done. But in r.d.sharma, whatever is the answer, we have to get it. So just take this tan x as sin x by cos x, tan theta as sin theta by cos theta, resolve it, and the final answer, let me write it. Okay, I am writing the final answer here. It's cot theta ln modulus of cos x. From here we got cos x by cos x plus theta plus constant of integration, and this constant of integration is actually a capital one, because when you solve this 1 by 1 minus tan x tan theta in terms of sin and cos, you look at a constant term also, and that constant term can be added with a constant of integration in order to get a new constant of integration, which is c dash, you can say. All right, now let me show you the result. This is your result we are talking about. So till the third step of the right side block, the answer has already come. Then we resolved it. This is sin 2x divided by sin x minus pi by 6 sin x plus pi by 6. Now sin pi by 6, let me tell you, it's 1 by 2. Just in case we encounter and we come to a point where we have to use it. Now the denominator is sin a plus b and sin a minus b. You can also call it as sin a minus b into sin a plus b. It's simply sin square a minus sin square b. You already know that. This is a standard result. So integration sign and dx will always remain. I'm not writing it. That doesn't mean you will not write it. You're going to write it all the time. This is just for your explanation or understanding of the logic. Sin 2x is in the numerator. Sin a plus b into sin a minus b will give you sin square a minus sin square b. This is sin square x minus sin square pi by 6. I told you sin pi by 6 is half, because sin 30 degree we are talking about. Sin 30 degree is half. Half square is 1 by 4. So sin square x minus 1 by 4 in the denominator will come. Okay, now it has become so easy. Sin square x will directly give you sin 2x. That you already know. So that is what we are going to use. Sin square x minus 1 by 4. You can take all the denominator as t. dt by dx will give you 2 sin x cos x. This minus 1 by 4 will just get eliminated. dt will be equal to 2 sin x cos x is sin 2x. Sin 2x into dx. So the numerator is already there with us. This integration will be dt divided by sin square x is going to be equal to, because that was sin square x minus 1 by 4 totally we have taken as t. So integration of this, you can just directly write it ln modulus of t plus constant of integration. In place of t, just replace it by sin square x minus 1 by 4. So it will be ln sin square x minus 1 by 4 plus constant of integration. This is your final result. Okay, this is the result we are just talking about. This sin a plus b into sin a minus b is very important here, right? Next one is e raise x minus 1 plus x raise e minus 1 divided by e raise x plus x raise e. Okay, let us take this denominator as t. So e raise x plus x raise e will be t. dt by dx will be what? E raise x remain e raise x. X raise e, actually x raise e is equivalent to x raise n. So when you differentiate x to the power n, it will be nx to the power n minus 1. So this will be e x to the power e minus 1. E x to the power e minus 1. So there are two ways you can do it. Either you take this e, that is x raise e minus 1 divided by x raise e minus 1 will be x raise e into x raise minus 1 divided by x. This is one way. The better way is to divide everything by e, because we need x raise e minus 1, we already got. But we need e raise x minus 1 also. So e raise x minus 1 will only come when you have this divided by, see, whatever I am doing, I am just trying it out. These are the trial and error method everyone has to follow, because every time you will not get the answer directly. So what I am suggesting here is just divide everything by e, because that I perceive already what are we going to get in the numerator. So I divided everything by e. So I have to divide the e on the left hand side also. So e raise x divided by e will give you e raise x minus 1. Here e gets cancelled, so the x raise e minus 1 remains. 1 by e is there, so dt by e is equal to the numerator already. So this numerator is simply dt by e. So you can take it as dt 1 by e you can take it outside. T is in the denominator. When you integrate it, it will be a 1 by e ln modulus of t plus constant of integration. T was taken as x raised e plus e raised x or e raised x plus x raised e. So 1 by e ln modulus of e raised x plus x raised e plus constant of integration is your final solution. So this is the solution I'm talking about. Let putting all the symbols, the since sign and the therefore sign and the all written material, the content should be like this. So 1 by sin x into cos square x dx. Now please understand this question because the next question is exactly like this. So sin square x plus cos square x, wherever we see sin square x, cos square x and a 1, we tend to write 1 as sin square plus cos square because sin square plus cos square is 1 only. So this sin square plus cos square divided by sin x cos square x will become sin square x remain in the numerator, sin x into cos square x goes in the denominator. So this sin gets cancelled. This is sin by cos square. So you can write it as sin x by cos x into 1 by cos x. Sin by cos x is 10x, 1 by cos x is sec x. So this sin by cos can be written as 10x. 1 by cos x is sec x. So we have a term which have direct integration. First term we have got. Now what do you get here? You can just cancel this cos square 1 by sin x. When sin x goes up, it will form cosec x. So we have to integrate these two now. We then just write that dx term and integrate it. We don't have to put anything as t here. Sec x tan x has a direct integration. What is integration? Sec x. Cosec x is what? ln modulus of cosec x will be cosec x minus cot x. It will be cosec x minus cot x plus constant of integration. Now you can make this cosec x minus cot x more simpler. Cosec x is 1 by sin x. Cot x is cos by sin x. So 1 by cos by sin. So this is tan x by 2. You already know that this is equal to tan x by 2. So in place of cosec x minus cot x, you can also come up with this tan x by 2 if you want. So these are the standard result. So sec x plus ln modulus of tan x by 2 plus constant of integration is your answer. So this is the result we were talking about. Please remember, wherever we have sin square, cos square involved and 1 is there, always take 1 as sin square plus cos square x. That will give you certainly some result. 1 by cos 3x minus cos x. So cos 3x and minus cos x. See, cos 3x is what? It's 4 cos cube x minus 3 cos x. You already know this formula. Without this formula being known, very difficult to attempt this question. So this cos, when we write cos 3x, since we have to equate it with cos 3x minus cos x, so this will be 4 cos cube x minus 3 cos x minus cos x, and that is going to give you 4 cos cube x minus 4 cos x. So I'm writing the denominator as 4 cos cube x minus 3 cos x minus cos x will become minus 4 cos x. So you can take 1 by 4 cos x common if you want, because it will give you certain result. You will just see. When you take this 4 cos x common, it will be cos square x minus 1 inside. And cos square x minus 1, you know that sin square x plus cos square x is 1. So what is cos square x minus 1? It's equal to minus sin square. 1 minus cos square is x is equal to sin square x. So cos square x minus 1 will be minus sin square x. So 1 by 4 cos x, this cos square x minus 1 will become minus sin square x. So 4 is already there, negative is already there. So what do we get here? Negative 1 by 4 and integration inside you will get. So it's 1 by cos x into sin square x. Now what is the similarity? See, in this question number 50th we are doing, and I'm doing and solving it in this question only. See, we have 1 by cos 3x minus cos x, remember? So now I'm just trying to equate it. So in place of 1, write sin square x plus cos square x, and cos x into sin square x is already in the denominator. So this will give you some cancellation. So sin square x gets cancelled, cos x will be sec x, and this you can cancel 1 cos and this 1 cos by sin into 1 by sin. Cos by sin is cot and 1 by so cos by sin is cot. It is cosec x because 1 by sin x is cosec x. So cosec x cot x you got. Sec x plus cosec x into cot x. So negative 1 by 4 will remain like that, and integration of sec x and integration of cosec x cot x will be done. So negative 1 by 4 is still there. We'll just introduce it in a short while, but we have to integrate these two terms. Sec x has a direct integration ln modulus of sec x plus tan x in the modulus. Modulus means absolute. Only the positive will come inside. And this cosec x cot x is already minus cosec x, a direct solution. So plus constant of integration you can do. Minus 1 by 4 is already there. So just multiply everything by minus 1 by 4. So 1 by 4 will remain like that, and if you multiply negative inside, you can just swap these two terms. It will be cosec x minus ln modulus of sec x plus tan x, and then we have the constant of integration here. This is your final answer. So this is the result we were talking about. It's straightforward now. Previous question is this one. We have done just this one. So this is how we have related with the previous question. That's how questions are interdependent actually. So this is all about this exercise. We have completed this one. Have a good one. Take care of yourself. Don't bother about subscribing or liking. It's up to you. Just learn.